In this video, I will be using the acrolein that I made in one of my previous videos to make ethyl vinyl ketone. Ethyl vinyl ketone is a reagent used for annihilation, which I will do for another video. Since it is quite expensive, I wanted to try to make it myself, but the reagent is very sensitive, so we'll see how it goes. So to get there, I need to do several reactions. First, I need to prepare a Grignard reagent of bromoethane. This is done by reacting it with magnesium in anhydrous diethyl ether. This Grignard reagent can then be used to perform a Grignard reaction. It will react with the acrolein and form a new carbon-carbon bond. At the end of that reaction, the molecule will be an alkoxide salt, which can then be turned into an alcohol by addition of aqueous acid. So after the Grignard reaction and workup, we are left with an alcohol, but we need a ketone in that place. So to transform the alcohol into a ketone, we can oxidize it. By dissolving the alcohol in DCM or chloroform, and then adding activated manganese dioxide, it will oxidize the alcohol group to a ketone. And in the end, we should have the ethyl vinyl ketone. So first things first, I will make the Grignard reagent. To make the Grignard reagent, I will only use chemicals that I bought from chemical companies. Before I set up the reaction, I will prepare a drying tube, which is just 2 bits of cotton with some calcium chloride in between. This will prevent moisture from the air entering the reaction setup. So I set up a 3-neck flask and add a dropping funnel, a stopper and a condenser. Then I attach the drying tube on top of the condenser. For now, this will be the setup for the preparation of the Grignard reagent, and I can move on to adding the reactants. First I add in 4 grams of magnesium turnings, and on top of that I add 40 ml of anhydrous diethyl ether. Then I place back the stopper and add a mixture of 12.1 milliliters of bromoethane and 80 ml of anhydrous diethyl ether to the dropping funnel. To allow the reaction to start, I open the funnel and let some of the mixture into the flask. It takes a while for the reaction to start, but it's best to do it slowly, since it can suddenly go out of control. Since not much was happening, I added a stir bar and started heating it slightly. I also added water cooling, since the reaction will likely produce too much vapors for just air cooling. I keep slowly adding the bromoethane mixture to the flask and make sure that it is lightly refluxing during the addition. What is happening here is that the magnesium reacts with the bromoethane to form ethyl magnesium bromide, which is an exothermic reaction, so it cannot be added all at once. The diethyl ether also plays a role here, since the ether helps to stabilize the compound. After all of the bromoethane has been added, I heat the mixture to let it reflux for another 15 minutes. When that is finished, I add some anhydrous diethyl ether to the dropping funnel, and then on top of that, I add in the acrolein that I made in one of my previous videos. I don't expect this acrolein to be very pure. It will likely contain some impurities, and will cause some side reactions to take place, but it should still make the desired alcohol product. So after everything was added to the dropping funnel, I slowly add the acrolein to the Grignard reagent. You can see that the reaction is pretty violent, and it instantly starts splashing the product everywhere. The reaction between the acrolein and the Grignard reagent forms an alkoxide salt, which is very insoluble in ether, so it immediately precipitates out. I slowly added all of the mixture to the flask, and when everything was added, the whole flask was covered in the alkoxide salt. Now I just leave it to reflux for about 15 more minutes to make sure everything has reacted. When that was finished, I moved it to an ice bath. The next step is to add some aqueous acid to the mixture, so I will add some dilute hydrochloric acid. Since it even splashed into the condenser, I will start there. This will turn the insoluble alkoxide into the alcohol product, which is a liquid that is soluble in ether, and it will also produce a magnesium salt, which is soluble in water. At first, I was a bit worried that my product was polymerizing, since it seemed to form some green chunks that stuck to the glass. But when I added the acid, it luckily disappeared. The reaction is done in an ice bath because it is very exothermic. If it is done too fast, all the ether and the product will splash out. After using some dilute acid, I moved on to using 37% hydrochloric acid, because I didn't want to add too much volume to the flask. As I was adding the acid, all the white stuff slowly started to disappear, and at the same time the magnesium was reacting with the acid to form soluble magnesium chloride and hydrogen gas. So when that was finished, I had 2 layers. Though it seems that using concentrated acid influenced the color, and I don't know why, so I just diluted it with some water. After doing that, it started to look yellow, which normally isn't good, but you know. So now I will simply separate the layers by putting them in a separatory funnel. The alcohol product should be fully miscible with diethyl ether and only slightly soluble in water. So pretty much all of the product should be in the upper ether layer. So I drain away and discard the water layer, and then wash the ether layer with some saturated sodium bicarbonate solution to destroy any remaining acid. And also with some saturated sodium chloride solution, which will take out most of the water. Then I set the ether layer up for distillation. At first, pretty much only diethyl ether is coming over, and when the temperature increases past the boiling point of ether, I put a vial underneath. This fraction should just be impurities and side products that I formed. Since my acrolein wasn't very pure, it likely made numerous side products which are coming over now. When the thermometer started reading 110 C, I swapped out the vial to collect the alcohol product, which has a boiling point of 114 to 115 C. As this fraction was coming over, the thermometer started to show the same temperature as the boiling point of my product, which is a good indication that it is actually the alcohol. After a while the temperature started to decrease and no more liquid came over, which indicates that pretty much all of the alcohol has come over. So I removed the vial and all that is left in the flask is a dark liquid, so we can see that there's still a lot of impurities left behind. The yield of this synthesis is about 20 to 25%, which I think is not super bad for the acrolein with questionable purity. Also, I don't have a literature source for this exact synthesis, so it could be that this is just a normal yield for this reaction. Anyhow, I should have enough of the 1-pentane-3-ol which I can do the next reaction with. This compound is actually used for flavoring and scent, albeit in a low concentration. But in high concentrations it is supposed to smell like pungent horseradish. But I'm not really too familiar with horseradish, so it is quite pungent, but the smell is not something that I recognize. Anyhow, for the next step I will need these three chemicals. To turn the 1-pentane-3-ol into 1-pentane-3-one, I need to oxidize it. But since I have an allylic alcohol, I can't just use any oxidizer, since the double bond is quite sensitive. So I will be using activated manganese oxide, which can oxidize under mild conditions, and it has a high surface area to allow for better reactivity. The reaction is mostly done in DCM or chloroform. Normally I would choose DCM over chloroform, but right now I ran out of dry DCM, so I will have to use dry chloroform instead. First I will measure exactly how much of the alcohol I have, since this will determine how much of the chloroform and manganese oxide I need to use. So it seems that I have a little over 10 milliliters of the alcohol. So I fill up a beaker with the chloroform and add in all of the alcohol to the flask and wash both the vial and the grad cylinder with the chloroform. Then I fill the flask a bit over halfway with the chloroform. So now I have a quite dilute solution of my alcohol and I can start adding the manganese oxide. So I add 15 equivalents of manganese oxide, which is around 130 grams. The manganese oxide is insoluble in chloroform and works by oxidizing the alcohol at the surface of the particles that float in the solution. The mechanism for this reaction is actually not completely known. Anyhow, now I can just let it sit here stirring at room temperature. Since the product will be more light and air sensitive, I cover the flask in aluminum foil. I come back after 24 hours and it looks pretty much the same, but it should have oxidized the alcohol to a ketone. So now I have to remove all the manganese oxide from the mixture. To do that, I will simply filter it through some cotton and sea light and wash it with some chloroform. I first add a little bit of hydroquinone as a stabilizer against polymerization. So I simply pour the contents of the flask into the funnel and let it filter through. I also added some fresh chloroform on top to wash the manganese oxide. And I also washed the reaction flask with chloroform. After a while most of it had filtered through, but I saw a small bit of manganese oxide got into the beaker, so I filtered it again through some cotton. Now that most of it has come through, I will set up the solution for a vacuum distillation. I will boil off the chloroform under vacuum, so that it can be done at a lower temperature. It took some hours to boil over most of the chloroform, but after it was done, I was left with a bit of remaining liquid in my flask. So I changed the setup to a smaller one and vacuum distilled it again. Now I hopefully have a mixture of chloroform, the product and water. So I will set this up for another distillation with an even smaller setup to minimize losses. Since I unfortunately broke my short path distillation apparatus, I have to do it without vacuum. So I have to see how it goes. I first collect everything that comes over under 70 C, which is mostly just chloroform. Then I swap the flask and collect everything until 100 C. The product forms an azeotrope with water that comes over at 86 C. After that the flask was basically empty and nothing more came over, and it didn't increase to the regular boiling point of 103 C of the product. It also didn't increase to the boiling point of the alcohol, so it seems that I have a very low yield that contains mostly water. Part of the product probably degraded because it is quite sensitive, but I'm not too certain where most of it went. It seems that the stuff that was left behind in the flask doesn't account for it. Perhaps a lot of it came over together with the chloroform in the initial distillation. Just as a check, I did a fractional distillation of all the chloroform that came over during this initial distillation and see if anything was in there, but it really didn't give me anything besides chloroform and water. Or maybe the leftover manganese dioxide should have been washed a lot better. Let me know in the comments where you think I failed. So in the future, when I want to do the annihilation with the ethyl vinyl ketone, I will have to buy it from Sigma, which will probably cost me €200 with tax and shipping for only 25 grams. So that will happen in the future when my wallet isn't empty. For now, a big thanks to my one and only Patreon supporter Michael for reducing my suffering. I appreciate it. And from now on, I will also post my methods and sources in text form to Patreon, which I write before making every video. I also give occasional updates about my projects, and perhaps more of you can join in, discuss and reduce my monetary suffering. Anyhow, thanks for watching, see ya.